Hello and welcome to the final video of this section, where we'll cover sequences and generators. In this video, we'll discuss both sequence type and generator type and explore their definitions in the Swift standard library. Finally, we'll create our own sequence and generator type objects. Throughout this section, we've heard the term generators and sequences, but only in passing. In this video, we'll cover all of the necessary pieces to create our own sequence type. Let's look at the sequence type protocol in Swift. I'll open up Xcode and type sequence type in any Swift file. As you're probably aware, we can right-click and jump to the definition of the type. This is the definition for Swift sequence type. At the top of the comments, we see that the Swift team describes sequence type, a type that can be iterated with a for-in loop. As we scroll down, we begin to see some familiar code. There's map, filter, for each. These functions become available to us for free when we create our own sequence type. This is great, but what we're interested in right now is this portion of the definition. These are the pieces we'll need in order to create our own sequence type. We'll need a generator type, which is type aliased as generator. Then we'll need to return a custom generator with a specific element type when generate is called. Now let's take a look at the generator type. I'll right-click on generator type and click Jump to Definition. As we can see, this is a simple protocol containing just one mutating function, next, which returns the next element in the sequence. Let's start by creating our generator type. We'll create a new playground and define a class named binary number generator. And we'll make it adopt the generator type protocol. Next, we'll define a few variables. Final, which will designate our ending point, and count, which will increment and eventually reach the value of our final variable. We'll need a simple initializer, of course, which I'm pretty sure you're comfortable with at this point. We'll also need a function named next that returns an int in order to conform to generator type. The logic herein needs little explanation. Let's create an instance, give it an ending point, and pass it into a while loop. And we see we're getting our next random binary numbers. However, if we try to call rand in a for-in loop, we get an error. In order to create a sequence type, we need a generator type. Having said that, creating our own generator type was merely an exercise, as Swift provides a generic generator for us, any generator of type T. A sequence type is so similar to what we just created that I'm simply going to copy our binary number generator and change a few names. We'll rename our class binary number sequence and make it adapt to the sequence type protocol. Then we'll change the function name from next to generate. We'll change its return type to an any generator with an int. And replace the logic with a closure named any generator. We'll instantiate our object and test our loop as before. And this time we get our binary numbers. To clarify the difference, generator type provides a next value, and we can call next over and over to get our next values. Sequence type utilizes a generator to return a sequence of values that we can simply loop over. In this video, we learned how we can create our own sequence types and generator types. In this section, we looked at how we can create our own extensions. We then learned how we can utilize generics to make our extensions more flexible for ultimate code reuse. We delved into higher order functions, which are a key component to functional programming in Swift. Finally, we looked at how to create our own sequences and generators. In the next section, we'll look at Swift's memory management system and learn how our programming choices can affect our application's memory performance.